Today we are learning. Today we are learning asymptotic notation. This is one of the most favorite topic in design analysis of an algorithm. What is an asymptotic notation complexity in analysis of an algorithm? Okay, we are having mainly three asymptotic notations. Okay, we have discussed asymptotic analysis, worst case, best case, and average case. The main idea of asymptotic analysis is to have a measure of efficiency of an algorithm that does not depend on a machine specific constants and do not require algorithm to be implemented and time taken by the program to be compared. Asymptotic notations are mathematically tools to represent the time complexity of an algorithm in asymptotic analysis. There are three types of asymptotic notations: big O, big omega, and big theta. Big theta notation. Theta notation encloses the function from the above and below. Since they are representing the upper and the lower boundaries of the running time of an algorithm, it is used to analyze the average case of the complexity of an algorithm. So O notation is for average case. Let G and F be the functions from the set of the natural number itself. The function as F is said to be O of G if there is a constant C1 and C2 which are more than 0 and natural numbers n of 0 such that C star G of n is less than or equal to F of n less than or equal to C2 star G of n for all n is more than or equal to n is more than or equal to n of 0. So this is the graph that we have to draw. In this graph, you can see we are looking from n of 0. Okay, that's our new point. In this point, f of n will stay between C1 and C2. Okay, C1 and C2 are two constants. Okay, so it will stay between them. Your f of n function will stay between these two. Mathematical representation, right? So this is the mathematical representation. O of g of n is equal to f of n. There exists a positive constant C1, C2, NO, and such that 0 is less than or equal to C1 and g of n is less than or equal to f of n and less than or equal to C2 star g of n. Okay. Big O notation. Big O represents the upper boundary of the running time of an algorithm. Therefore, it gives the worst case of an algorithm. If f of n describes the runtime of an algorithm, f of n is O of g of n. If there exists a positive constant c and n of 0 such that O is less than or equal to f of n, is less than or equal to c into g of n for all n more than or equal to n of 0. तो n of 0 तो यहाँ पर क्या है आपका बिटवीन x एक्सिस और c ऑफ g ऑफ n के बीच में रहेगा कौन f ऑफ n कौन है ये बिग O नोटेशन है इसको मैथमेटिकली कैसा रिप्रेजेंट कर रहे हैं अपन ओ जी ऑफ n इज इक्वल टू f ऑफ n. For example, consider a case of insertion sort. It takes linear time in the best case of a quadratic time. In the worst case, we can safely say the time complexity of the insertion sort is O of n square. We use O notation to represent the time complexity of the insertion sort. We have used two statements for best and worst case. The worst case time complexity of insertion sort is O of n square. The best case time complexity of insertion sort is O of n. The big O notation is useful when we only have upper boundary bounded on time complexity of an algorithm. Many times we easily find upper boundary of a simple looking at it at the algorithm. Omega notation. Omega notation represents the lower boundary of the running time. So ये lower boundary है ना C of G of n. Okay, तो यहाँ पर क्या था पहले big O notation upper boundary बता रहा था. Okay, आपका ओ नोटेशन जो था, बिग ओ नोटेशन, थीटा नोटेशन। ओके, बिग थीटा क्या कर रहा था, अपर और लोअर के बीच में। बिग ओ नोटेशन में क्या है, ओनली अपर। और बिग ओमेगा में क्या है, ओनली लोअर। तो इसके ऊपर हो सकती है एफ ऑफ एन की वैल्यू एक पॉइंट के बाद। और इसका ये मैथमेटिकल नोटेशन है। ओके, नाउ asymptotic notations are done. It's very easy topic, right? Don't forget to like, share, and subscribe my video. Thank you, guys.